Hello dear students, in this video we will see the previous year questions and questions from sample papers from chapter 3a, which is Differentiation and Its Applications. Here we have the questions from last year's term 1 board paper. The function f of x equal to a raised to x is increasing on R if. So we have to find the values which a can take such that f of x equal to a raised to x. It is an increasing function on R. So here we are given f of x is equal to a raised to x. From this let us find f dash of x. So f dash of x is a raised to x into log a. And now we have this function f, it will be increasing on R when f dash of x is more than 0. So this implies a raised to x into log a. This should be more than 0. Now we have a product of two expressions. So we have this expression more than 0 when a raised to x more than 0 and log a more than 0, or a raised to x less than 0 and log a less than 0. So the condition such that a raised to x log a will be more than 0 is that we have to have either a raised to x and log a more than 0 or a raised to x and log a less than 0. Now having a logarithmic function less than 0 is not possible. This is not possible. So from this we have log a more than 0. Now we know that log 1 is equal to 0. So here log a will be more than 0 when a is more than 1. So this implies a is more than 1. So the correct option is option D. This function f of x equal to a raised to x is increasing on R if a is more than 1. The next question, if c of x and r of x are respectively cost function, revenue function, then the profit function p of x is given by. So we have these four options. We know that the profit function is given by revenue function minus the cost function. So here we have p of x equal to r of x minus e of x. So the correct option is option C. Now we have the next question, if y equal to a e raised to 5x plus b e raised to minus 5x, then we have to find d square y by dx square. So here y is given as a e raised to 5x plus b e raised to minus 5x. So from this we can differentiate y. So dy by dx will be 5a e raised to 5x minus 5b e raised to minus 5x. Then d square y by dx square will be the derivative of this. So this is 5a into e raised to 5x is 5 e raised to 5x minus 5b into derivative of e raised to minus 5x is minus 5 e raised to minus 5x. So this is 25a e raised to 5x plus 25b e raised to minus 5x. Here 25 is common, which can be taken outside. So it is 25 into a e raised to 5x plus b e raised to minus 5x. Now this is nothing but this is y. So this is equal to 25y. So d square y by dx square, it is equal to 25y. Correct option is option A. Next question, the point on the curve x square equal to 2y, which is nearest to the point 0, 5 is. So here we have to find the point on this curve which is nearest to the point 0, 5. So here let us take, let the point on the curve be x, y. Then the distance between this point px, y on the curve and this point 0, 5, it is given by the distance formula d equal to root of x minus 0 the whole square plus y minus 5 the whole square, or we have root of x square plus y minus 5 the whole square. Now with this x square, it is nothing but it is equal to 2y. So this is root of 2y plus this, let us expand. Y minus 5 the whole square is y square plus 25 minus 10y. This is since x square equal to 2y. So from this we have d equal to root of y square minus 8y plus 25. And now we have to minimize this distance. If we have square root, then it will be difficult. So let us take z as d square. So to minimize z equal to d square equal to y square minus 8y plus 25. So we have to find the value of y for which z is minimum. Now dz by dy at the critical point, dz by dy equal to 0 implies 2y minus 8 equal to 0 or y equal to 8 by 2, which is 4. So here we have x square equal to 2y. When y equal to 4, x square equal to 2 into 4, which is 8. 8 is, it is 2 cube. So from this we have x is equal to plus or minus 2 root 2. Therefore, the points at which the distance is minimum are plus or minus 2 root 2 comma 4. So here among the options we have option A, which is 2 root 2 comma 4. So the point on the curve which is nearest to this point 0 comma 5, it is 2 root 2 comma 4. So the correct option is option A. Next question, the total revenue in rupees received from the sale of x units of a product is given by r of x is equal to 3x square plus 36x plus 5. Then the marginal revenue when x equal to 15 is. So here the total revenue function is given. We have to find the marginal revenue when x is equal to 15. So this is a very easy question. We know that marginal revenue equal to dr by dx, it is 6x plus, we have 6x plus 36. When x equal to 15, marginal revenue is, marginal revenue at x is equal to 15 is dr by dx at x equal to 15. So it is 6 into 15 plus 36, which is 90 plus 36, which is 126. So the correct option is option D, rupees 126. So rupees 126 is the marginal revenue when x is equal to 15 for this revenue function. The next question, equation of normal at the point 1 comma 1 to the curve 2y plus x square equal to 3 is. So we have to find the equation of normal at this point to this curve. This is also a very easy question. So here the given curve is 2y plus x square equal to 3. Now let us differentiate both sides with respect to x. So we have 2 dy by dx plus 2x equal to 0. From this we have 2 dy by dx equal to minus 2x, or dy by dx is minus x. Now we need to find the equation of the normal at this point 1 comma 1. So dy by dx at 1 comma 1, it is minus 1. Now we can find the equation of the normal at 1 comma 1 as y minus y1 equal to minus 1 by dy by dx at 1 comma 1 into x minus 1. Here y1 and x1 are 1 and 1. So we get y minus 1 equal to minus 1 by minus 1 into x minus 1. So this becomes positive, or we have y minus 1 equal to x minus 1 minus 1 will go. From this we get x minus y equal to 0. So this is the equation of normal at 1, 1 to the given curve. So the correct option is option B, which is x minus y equal to 0. Next question, the least value of a such that the function f of x equal to x square plus ax plus 1 is increasing on open interval 1, 2 is. Here we have to find the least value of a such that we have this function increasing on this open interval. So given f of x is equal to x square plus ax plus 1. So from this we have f dash of x equal to 2x plus a. Now we have f will be increasing in 1, 2. If f dash of x greater than 0 in open interval 1, 2. So from this we get f dash of 1 equal to 2 plus a greater than 0, which implies a is greater than minus 2, and f dash of 2 equal to 4 plus a. This should also be greater than 0, implies a is greater than minus 4. So here we have to find the least value of a such that we have this function increasing on 1, 2. So we got a greater than minus 2, a greater than minus 4. So on this number line, if we have minus 4 here, minus 2 here, then a greater than minus 4 it is this part, and a greater than minus 2 is this part. So the region which is common to these two is a greater than minus 2. So the least value of a is such that this function is increasing on 1, 2. It is minus 2. So a is greater than minus 2. Next question, the demand function of a commodity is given by x is equal to 82 minus p, and its total cost function is given by total cost equal to 100 plus 60x. For maximum profit, the value of x is. Now since last year we had this exam as MCQ, this question was given in MCQ, otherwise a question of this type will carry 5 marks. So here the demand function is given, the total cost function is given, we have to find the value of x for which the profit is maximum. So here we have demand function as x is equal to 82 minus p. So from this we can write p equal to 82 minus x. Now we know that the revenue function, it is given by p into x. So from this we get revenue function as 82x minus x square. Here the cost function is given in the question itself. So cost function c of x equal to 100 plus 60x. So from this we can find the profit function p of x as revenue function minus the cost function. So it is 82x minus x square minus 100 minus 60x. So this is 22x minus x square minus 100. Now we have to maximize this profit function. To maximize, p of x is equal to this function. And now after this it is easy to proceed. We have to find the critical point and then we have to use the second derivative test to find the point of maxima. Now p dash of x equal to 0 implies 22 minus 2x equal to 0 or 22 equal to 2x. From this we get x is equal to 22 by 2, which is 11. P double dash of x, here p double dash of x is minus 2 equal to minus 2 less than 0 for all x. Therefore x equal to 11 is a point of local maxima. So for maximum profit, the value of x is 11 units. So the correct option is option D. So these are the various questions from last year's term 1 board paper. Now we will see the questions from last year's sample question paper. The total cost function is given by C of x is equal to x square plus 30x plus 1500. The marginal cost when 10 units are produced is. Again, this is also a very easy question. The cost function is given. We have to find the marginal cost when 10 units are produced. So marginal cost equal to C dash of x. This is equal to 2x plus 30. So marginal cost at x is equal to 10 is C dash of 10. So it is 2 into 10 plus 30, which is 50. So the correct option is option C, rupees 50. The next question, the function y equal to 1 by x is strictly decreasing in the intervals. We have these 4 options. So we have the function y equal to 1 by x, and we have to see where this function is strictly decreasing. Now given y equal to 1 by x, from this dy by dx is minus 1 by x square. So y will be strictly decreasing when the derivative of y is less than 0. That is dy by dx is less than 0. If dy by dx less than 0. This implies minus 1 by x square less than 0 or 1 by x square is greater than 0. So the points where 1 by x square is greater than 0, it consists of x belong to the entire real numbers minus 0 alone, because here we have 1 by x square, here x not equal to 0. Therefore, this function 1 by x is strictly decreasing in the interval open interval minus infinity comma 0 as well as open interval 0 comma infinity. So it is strictly decreasing in the entire number line except the point 0, except the point 0. So the correct option is option C. Next question. The equation of tangent to the curve y equal to x cube plus x at the point 1 comma 2 is. Again, this is also easy question. From this we can find the slope of the tangent and we can find the equation of the tangent at this point. So the given curve is y equal to x cube plus x. So if we differentiate with respect to x, we get dy by dx equal to 3x square plus 1. Now the slope of the tangent, it is given by dy by dx at 1 comma 2. So this is 3 into 1 square plus 1, which is 4. So the slope of the tangent is 4. The equation of the tangent at 1 comma 2 is given by y minus y1. y1 is 2. y minus 2 equal to the slope of the tangent dy by dx at 1 comma 2 into x minus x1. x1 is 1. So from this we get y minus 2 equal to slope of the tangent we just now found 4 into x minus 1. So this is 4x minus 4. Now here we have all the options as 4x. It starts with 4x. So let us bring the constant to the right hand side. So it is minus 2 plus 4 equal to 4x minus y or 4x minus y equal to 2. So the correct option is option B. Moving on to the next question. The function y equal to mod x is, we have these 4 options, neither differentiable nor continuous at x is equal to 0, differentiable at and continuous at x is equal to 0, continuous but not differentiable at x is equal to 0, differentiable but not continuous at x is equal to 0. Now here, if you remember the curve of mod x, it is a V-shaped curve. So this is the curve for mod x. Now here we can see that it is continuous. On the other hand, there is a turning point at x is equal to 0. As a result, it is not differentiable at x is equal to 0. So the correct option is option C. It is continuous but it is not differentiable at x is equal to 0. Next question, given that x is equal to at square and y equal to 2at, then the value of d square y by dx square is. Now this is differentiation of parametric functions. Here we have x as a function of t and y as a function of t. We have to find d square y by dx square. So for that we have to find dx by dt and dy by dt. Now dx by dt, it is equal to 2at and dy by dt is equal to 2a. So we have dy by dx equal to dy by dt upon dx by dt. dy by dt is 2a upon dx by dt is 2at. So this is 1 by t. Now d square y by dx square, it is d by dt of dy by dx, d by dx of dy by dx. But here we have dy by dx as a function of t. So again using chain rule, we can write this as d by dt of dy by dx into dt by dx. As a result, we have d square y by dx square as d by dt of dy by dx, the whole thing divided by dx by dt. So it will be easy if we remember this relation between d square y by dx square when we get dy by dx as a function of t. So d square y by dx square, we calculate it as d by dt of dy by dx is 1 by t upon dx by dt, we have it here 2at. Now derivative of 1 by t is minus 1 by t square, the whole thing by 2at. So this is minus 1 by 2at cube. So the correct option is option A. This is d square y by dx square. Moving on, the variable cost of producing x units is V of x is equal to x square plus 2x. If the company incurs a fixed cost of rupees 10,000, then the level of output where the average cost is minimum is. So here the variable cost is given and then the fixed cost is given. We have to find x for which average cost is minimum. So it is important that the question should be read properly. Here the variable cost function is given as x square plus 2x and fixed cost is given as rupees 10,000. So the total cost function is the sum of the variable cost and the fixed cost. So it is x square plus 2x plus fixed cost, which is 10,000. Now we know what is average cost. Average cost is the total cost function divided by x. So we have to divide this entire thing by x. When we divide by x, we get x plus 2 plus 10,000 upon x. Now we have to minimize this average cost. To minimize average cost equal to x plus 2 plus 10,000 by x. And now after this it is very easy. We can use the second derivative test. That is, we can find the critical points by equating the derivative of average cost to 0, and then we can find the points where it is minimum. Now d by dx of average cost equal to 0 implies the derivative of x plus 2 plus 10,000 upon x. It is 1 minus 10,000 by x square equal to 0. So from this we get 1 equal to 10,000 upon x square, or we have x square equal to 10,000. So we have x as plus or minus 100. We cannot have minus 100 since it is the level of output. Therefore, x equal to 100 units. And now we have to use the second derivative test. So d square by dx square of the average cost. That is we have to find the derivative of this. So it is minus 10,000 into minus 2 by x cube. So this is 20,000 by x cube. This is greater than 0 when x equal to 100. Therefore, the level of output where the average cost is minimum is 100 units. So the correct option is option C. Moving on, the next question, the demand function of a toy is x is equal to 75 minus 3p and its total cost function is 100 plus 3x. For maximum profit, the value of x is. Now we have to find the value of x for which the profit is maximum. Here again the demand function is given and the total cost function is given. From this we can find the profit function after finding the revenue function. So the demand function is given as x is equal to 75 minus 3p. From this we have 3p equal to 75 minus x, or p equal to 75 by 3 minus x by 3. So this is 25 minus x by 3. And now the revenue function, it is given by r of x is equal to p into x. So it is 25x minus x square by 3. The total cost function is given here directly, which is 100 plus 3x. The profit function p of x is given by r of x minus c of x. So it is 25x minus x square by 3 minus 100 minus 3x. So it is 22x minus x square by 3 minus 100. So this is the profit function. Now we have to maximize this function. To maximize, p of x is equal to. So we have at the critical points p dash of x equal to 0 implies 22 minus 2x by 3 equal to 0. This implies 22 equal to 2x by 3. Here this will go 11 times, or x is equal to 33. Therefore x is equal to 33. Now p double dash of x, it is equal to, when we differentiate this again, we get it as minus 2 by 3. This is less than 0 for all x. Therefore x is equal to 33. It is a point of local maxima. So the value of x for which the profit is maximum is 33. So the correct option is option A, 33. Moving on. Now these are the questions from this year's sample paper. We have this question for 3 marks. Find the intervals in which the function f of x equal to x raised to 4 by 4 minus 2x cube plus 11x square by 2 minus 6x is strictly increasing and strictly decreasing. So this is the same question is given as example in the CBSE Handbook. So here we have to find the intervals in which this function is strictly increasing and strictly decreasing. So here given f of x is equal to x raised to 4 by 4 minus 2x cube plus 11x square by 2 minus 6x. At the critical points, f dash of x equal to 0. This implies we have to differentiate this. So it is 1 by 4 into derivative of x raised to 4 is 4x cube minus derivative of x cube is 3x square. So 2 into 3x square is 6x square plus 11 by 2 into derivative of x square is 2x minus derivative of 6x is 6. This is equal to 0. This implies x cube minus 6x square plus 11x minus 6 equal to 0. Now here we have a polynomial of degree 3. So let us try x as 1. F dash of 1 is 1 minus 6 plus 11 minus 6. This is 12 minus 12. This is equal to 0. As a result, for this polynomial equation, we have x is equal to 1 as a root. Since we have this equation, it is satisfied for x is equal to 1. Therefore, f dash of x is equal to x minus 1 into. Now we have to divide this x cube minus 6x square plus 11x minus 6 by this x minus 1 to find the other factor. So for that we can use synthetic division. So here the coefficient of x cube is 1, x square is minus 6, coefficient of x is 11 and the constant term is minus 6. Here we have the factor as x minus 1. So here it is positive 1. Bring this 1 directly here. Now 1 into 1 is 1. Add these two, minus 6 plus 1 is minus 5. Then 1 into minus 5 is minus 5. This is 6. 1 into 6 is 6. Then minus 6 plus 6 is 0. Now this represents the coefficient of x square. This represents the coefficient of x. This is the constant term and this is the remainder. Here the remainder is 0. So we have x minus 1 into x square minus 5x plus 6 equal to 0. Now we can factorize this. So from this we have it is x minus 1 into, here the factors are 2 and 3, x minus 2 into x minus 3 equal to 0. From this we get x is equal to 1, 2 and 3 are the critical points. So finding the critical points, it carries 1 mark. Now we can divide the entire number line into intervals from minus infinity to 1, then 1 to 2, 2 to 3 and 3 to infinity. So the various intervals are minus infinity comma 1 open interval 1 comma 2, open interval 2 comma 3 and open interval 3 comma infinity. So here starting from the right we have the sign of f dash of x as positive, negative, positive, negative. So on this interval open interval minus infinity comma 1, the sign of f dash of x is negative. F dash of x less than 0. As a result, on this interval f is strictly decreasing. Next we have the next interval 1 to 2. Here f dash of x is positive. As a result, f is strictly increasing. Then we have the next interval 2 comma 3. Here the sign of f dash of x, it is again negative. F dash of x is less than 0. So f is strictly decreasing on this interval. Then we have the last interval 3 to infinity. Here f dash of x is positive. As a result, f is strictly increasing on this interval. So the intervals on which f is strictly decreasing is minus infinity comma 1 union open interval 2 comma 3. And the intervals on which f is strictly increasing is open interval 1 comma 2 union open interval 3 comma infinity. So these are the intervals where f is strictly increasing and strictly decreasing. So here finding the critical points, it carries 1 mark. Then finding the intervals where f is strictly increasing carries 1 mark and strictly decreasing carries 1 mark. So a total of 3 marks for this question. Now we have the next question from this year's sample paper. It is a 5-mark question with internal choice. So let us see each question one by one. An event management company charges rupees 4,800 per guest for a bulk booking for 100 guests. In addition, it offers a discount of rupees 200 for each group of 10 guests over and above 100 guest booking. What is the number of guests that will maximize the amount of money the company receives on a booking? What is the maximum profit on such booking? So here we can see that an event management company, it charges rupees 4,800 per guest for bulk booking of 100 guests, and then it offers a discount of rupees 200 for each group of 10 guests over and above 100 guests. So we have to find the number of guests that will maximize the amount of money that the company will receive and also the maximum profit. So let X be the number of guests for the booking. Then the profit per guest, it is given by, here we have, if we have X is equal to 100, then the profit per guest will be 4,800. So it is 4,800, and if it is over and above 100 guests, then it offers a discount of rupees 200 for each group of 10 guests. So it is 4,800 minus 200 by 10 into X minus 100. So this, if we simplify, it is 4,800 minus 20x plus 2,000, or it is 6,800 minus 20x. And now this is profit per guest. The total profit will be the number of guests into profit per guest. We have taken X as the number of guests. So the total profit will be X into 6,800 minus 20x. So this is 6,800x minus 20x square. So this is the profit function. We have to maximize P of x equal to 6,800x minus 20x square. So after this, it is very easy. After this, we have to use the second derivative test to find the value of Px that will maximize this profit function. So we have at critical points, dp by dx is equal to 0. So dp by dx is 6,800 minus 40x. This is equal to 0. So from this we can find x. 6,800 equal to 40x, or 6,800 divided by 40 equal to x. Therefore, x is 170. And now let us find d square p by dx square. So from here, d square p by dx square, it is negative 40. It is minus 40, which is less than 0 for all x. Therefore, x is equal to 170 is a point of local maxima. So the number of guests that will maximize the amount of money is 170 guests. They are also asking the maximum profit. The maximum profit, it can be obtained by substituting x equal to 170 in this profit function. Maximum profit is P of 170. It is 6,800 into 170 minus 20 into 170 the whole square. So this is 8,16,000 minus 170 square into 20, it is 2,38,000. So this, when we simplify, we get it as 5,78,000. So this is the maximum profit. So here we have the result. A booking for 170 guests will maximize the profit of the company, and maximum profit is equal to rupees 5,78,000. So here, finding the profit function, it carries 2 marks. Then finding dp by dx carries 1 mark, d square p by dx square carries 1 mark. The remaining steps and the final answer, it carries 1 mark. So a total of 5 marks for this question. We have a similar question in the CBSE Handbook in the last exercise of chapter 3A, Differentiation and Its Applications. Now we have the or part of the same question. There is an internal choice in this question. To manufacture X number of dolls, a company's total cost function C of X is given by C of X equal to 100 plus 0.025x square, and total revenue function R of X is 5x. Given that C of X and R of X are in 1000 rupees, what number of dolls shall be manufactured to maximize the profit of the company, and what is the maximum profit? So this is a very easy question. Here they have given the cost function and the revenue function directly. From this we can find the profit function as revenue function minus cost function, and then we can find the value of X for which the profit function is maximum. So given total cost function, it is 100 plus 0.025x square, and then revenue function is given as 5x. So from this we have profit function given by R of X minus C of X. Function as 5x minus of, so it is minus 100 minus 0.025x square. Now we have to maximize this profit function. To maximize P of X equal to 5x minus 100 minus 0.025x square. So for that, first we have to find dp by dx. It is equal to 5 minus 0.05x. At critical points, dp by dx is 0. So from this we get 5 minus 0.05x equal to 0, or x is equal to minus 5 by minus 0.05, which is 100. Therefore, x equal to 100. And then d square p by dx square, it is equal to, from here we can see that it is minus 0.05. This is less than 0 for all x. Therefore, x is equal to 100 is a point of local maxima, and the maximum profit is given by, maximum profit is P of 100 equal to 5 into 100 minus 100. We have to put x as 100 in this profit function. Minus 0.025 into 100 square, it is 10,000. So this is 500 minus 100, 400 minus, this is 250. So 400 minus 250 is 150. And here it is given the cost function and the revenue function are in 1000 rupees. As a result, the profit is 150 followed by 3 zeros, so it is 1,50,000. It is rupees 1,50,000. So manufacturing 100 dolls will maximize the profit of the company, and maximum profit is rupees 1,50,000. So here again, writing the profit function carries 2 marks, then dp by dx 1 mark, d square p by dx square 1 mark, the remaining steps and the result, the final result carries 1 mark. A total of 5 marks for this question. So these are the various questions from the previous year question paper and sample papers on differentiation and its applications. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.